Good morning, all. I welcome you all for today's lecture series. So, in this series, we are going to see PN junction device. Is the unit 1 of analog electronic circuit, and our triple students are going to study second semester. So, based on this PN junction devices, we have to discuss PN junction diode, Zener diode, and rectifiers, full wave rectifier and half wave rectifier, PV cells, all those things in this unit. So, based before we are going to the session, so you have to recollect what are the information as we know before we enter into the session. So I think PN junction diode already you all studied in the first semesters in FEEE, and I think shall I ask some questions from basic questions? Okay. So first you have to tell what is PN junction. Yes, it is the region between the P-type material and the N-type material. We can say it is the junction. And I think it has another name for the junctions. Anyone? So of course it's a depletion region. So depletion region means there is a region between the P material and the N material joined together. That is a junction is created that we called as the PN junction region, or we can say it is the depletion region. So next we're going to see already we know that is what is semiconductor. First we have to recollect the information what is semiconductor and what type of P material and N type material join, and that's why we are discussing. And now before the question we have read, I have decided we have discussed, and can a diode conduct a current in both directions? Definitely not. It is a unidirectional. And why do we use diodes and rectifier? Because it's rectifying from AC supply into DC supply. So these are the recollection informations, and we are going to discuss what is meant by diode, construction, type of diodes, and the characteristics, and the real-time industry's role in PN junction diodes. And so this is the PN junction diode picture. So I show you that this is the diagram, and this picture is consists of 3/4 of black and 1/4 of silver. And if you are going for the lab, if you are asking PN junction diode, and it looks like this picture. And then normally we are draw the symbol. It has two terminals. One is anode terminal and then the cathode terminal. And the anode terminal we can draw in the triangle shape, and cathode terminal we can draw in the line. So join together, and there are two terminals. We can draw the PN junction diode symbol. All right. So in this diagram, we can see the yellow color. It is the PN junction region. And here already we have discussed there is a P material and N material are joined together, and it forming a junction. Right. And so P side and we are working already. We are discussed the PN junction works in a unidirectional one. And construction base, there is two type of semiconductor materials are there. One is intrinsic and extrinsic. So intrinsic means there is a number of holes and electrons are same, and the extrinsic means the impurities added with the semiconductor, the conduction will be increased, and the intrinsic semiconductor does not have a conduction. And based on the material we have added, it can be changed into the P type or N type. For example, if you are chosen a silicon material as a semiconductor, along with this you are adding a trivalent, that is boron, indium, aluminum, it can be changed into the um, P-type material. And pentavalent material, that is phosphorus, arsenic, and antimony, it can be changed into the other type of material. So Here I have to show you the trivalent material, that is p-type, that is gallium, germanium, that is silicon or germanium is the semiconductor. Along with this trivalent material added, that is impurities added, it can converted as a p-type, and pentavalent impurities added with the germanium or silicon, it can be changed into the n-type material. So if you are adding these two material, we can construct a PN diode. So this is the construction, and normally you can say the P material consists of a number of majority and minority carriers. So majority carriers in P-type material is positive, and the N-type method is holes. And the N-type material, and it can and it acts as the majority, and minority also is there. The electrons are acting as the minority carriers. In N-type material, electrons are majority carrier and holes are minority carrier, and it shows in the diagram. Here it shows the diagram, that is the positive, the plus with the circle is holes, and electrons are there, and the minimum number of electrons are there. And here is the maximum number of electrons and the minimum number of holes are there. And after joining together, there is a potential, there are barrier potential, that is the region formed, that we called as the barrier potential. And if you are there is no current flow between p-type material to n-type material. If you are adding a bias voltage, that is external voltage through the battery, it can be broken, and the current will be flow from p-type to n-type. And based on the material we are chosen, silicon material or germanium material, the silicon consists of 0.7 volt, and germanium 0.3. If you are connecting the battery p-type to p terminal to in a p-type material, and n terminal to, that is the positive terminal to positive, and negative terminal to negative, we can say it is a forward bias. And p-type that is p-type material connected to the battery of negative, and n-type material connected to the terminal of positive, we can say it is a reverse bias. So if you are applying the voltage beyond the limit of 0.7 and 0.3 voltage, then the diode will be conduction, and it's working. And this is the working of working principle, that if you are applying the more number of current voltage, then it will be work from current flow from positive to negative, then the current will be flow, and electron flow will be takes place. Okay, so I think today we are discussed in depth of PN junction diode material and type of material, and along with this working, and how to find the symbol, and how to draw the symbol, and how to remember the symbol. You have to draw positive and negative, that is anode and cathode material regions. So all those things we are discussed in this video. See you in the next video.